Alright, in this lesson we're going to continue moving forward with equations, looking at some more complex equations. And these will have variables on both sides of the equation, so your learning target is that you'll be able to solve more complex equations with variables on both sides. And then at the end of this lesson we're going to look at a couple of special cases. So, I hope that you're tracking and that you are getting good at showing your work and learning how to be good equation solvers. That is the foundation for algebra, so this skill is super important moving forward in all of your future math classes. Now, if you look at this equation, you're going to notice that on the left-hand side and on the right-hand side, they're just two expressions that you can use the distributive property to simplify. So first thing I'm going to do is distribute the 4. 4 times 2x is 8x, and 4 times 1 is 4. Remember, these two terms are not like terms, so I can't add them together. I have to just leave it like that. And that's equal to, on the right-hand side, I'm going to distribute the 2 to get 2x minus 2 times 13 is 26. Now, in a previous lesson, we discussed how, at this point, you choose a variable side and a number side. Now, I chose the variable side to be on the left because 8x is a bigger variable than 2x. When it comes down to it, it really doesn't matter. All that this does really is helps you not have negative numbers that you have to deal with in the end. So, since 8x plus 4 is my variable side, I want to get rid of anything that isn't a variable. I'm going to subtract 4. And what I do on the left-hand side, I do on the right-hand side, and I line it up with the other number. In the same step, since 2x minus 26 is my number side, I want to keep numbers and get rid of anything that's not a number. I'm going to subtract 2x. What I do on one side, I do on the other side. So in this one step, I get all my numbers on one side, the variables cancel, and all my variables on the other side, the numbers cancel. 8x minus 2x is 6x equals negative 26 minus 4 is negative 30. Now I simply divide both sides by 6 and solve the equation to get x equals negative 5. Alright, we took a complicated problem in the beginning, did a little distributing, and then solved the equation using the method you taught in a previous lesson. That you learned in a previous lesson. I taught it, not you. Alright, the second problem gets slightly more complicated. What you'll notice is one side you have to distribute the 7, and on the other side you have to distribute the 3, but there's also an extra term out here. So we're just going to treat each side like it's an expression of its own and start by distributing the 7 on the left-hand side. 7 times 4, 28. 7 times minus x is minus 7x. On the right-hand side, I'm going to distribute the 3, but remember I'm only distributing it to the terms inside the parentheses. I'm not going all the way over here to the 5x. So 3 times x is 3x, minus 3 times 4 is 12, plus the 5x at the end. And now, in this side, on this side of the equation, I do have like terms, 3x and 5x, so I'm going to add them together and get 8x minus 12. Over here I get 28 minus 7x. Now, looking at both sides of the equation, I notice that negative 7x is not the biggest term, but 8x is, so I'm going to make this my variable side. That makes the other side automatically my number side. So on the variable side, I'm keeping the variables. I'm getting rid of the number, so I'm going to add 12. What I do on one side, I go over here, do it on the other side, and put the number with the number. Over here, I want to get rid of this 7x, or minus 7x, so I do the opposite, so I add 7x. add 7x. Again, on the variable side, I want just my variables because the numbers cancel out. On the number side, I just want plain old numbers, the variables cancel out. 8x plus 7x is 15x. 28 plus 12 is 40. Now I finish it off. Divide both sides by 15. Now, in one of the assignments, I had people asking me questions about whether or not all the answers should come out to be nice and pretty whole numbers or integers. And the answer is no. Sometimes you get a fraction answer. So 40 over 15 is an okay answer, but it should be reduced. This number can be reduced because each of them is divisible by 5. 40 divided by 5 is 8. 15 divided by 5 is 3. And that's it. You can keep your number answers or your fraction answers, keep them as improper fractions like 8/3. You don't have to make it a mixed number. You do not want to make it a decimal number by dividing with a calculator. Just reduce the fraction and call it good. Okay, now when you're solving equations, what you're really doing is you're trying to figure out the value of x that makes both sides of this equation equal. You want this side to be equal to this side, and you have to find the number x that makes that true. So we found it in this problem. It was 8/3. In the first example, the number was -5 that made both sides of this equation equal or the same. Sometimes when you're solving equations, though, you don't come up with an answer. Sometimes you get an answer that's a special solution. So I'm going to show you two by looking at two different examples. So in this problem, first thing I have to do, distribute the 2. 2 times 5 is 10x, plus 2 times 6 is 12. Alright, now, at this point, what you should notice is that this side of the equation, 10x plus 12, is exactly the same as this side, 10x plus 12. And when that happens, when the variables are still there, if one side is exactly the same as the other side, then you say that this equation has an infinite number of solutions. Or I'm just going to write infinite solutions, and that's the abbreviation for solution. Another way to say this is called the identity. And the way I remember it is if one side is identical to the other side, then it's the identity, or it has infinite solutions. And all that means is it doesn't matter what value of x I choose. If I said I want x to be equal to 1, then a value of 1 here and a 1 here would make both sides of the equation true. If I said I wanted x to be 10, same thing. If I put 10 in place of x in both cases, then both sides of the equation are true. This is the identity, or infinite solutions. Okay, the other special case is an example that looks like this. Sorry, minor technical difficulty. So this is an equation that's also a special case, or special solution, and you'll see why in just a second. But if I start by distributing the -3, -3 times -3x is 9x, and -3 times 5 is -15. Now, at this point, I'm going to choose a variable side and a number side. Notice that both of the variables, 9x and 9x, are the same. So I just have to pick one side to be the variable side and one side to be the number side. And now I move forward. I'm going to take the variable side and I'm going to add 4 to both sides to get rid of the number. And on the number side, I'm going to add or subtract 9x from both sides to get rid of the variable. And something interesting is going to happen. On this side, the 9x's cancel, and -15 plus 4 is -11. On this side, the negative 4 and positive 4 cancel, and when you add 9x and negative 9x, you get 0x, or just 0. And the interesting thing that happens is, in this case, all of the variables cancel out and disappear, and you're left with an equation that says 0 equals negative 11. Now, does 0 equal negative 11? No. So at this point you would say no, because there's no solution. So the two special solutions or special cases are this one, where all the variables drop out and you end up with an equation that is not true and there's no solution. Or this equation where one side is identical to the other side, so you say you have the identity or infinite solutions. And that is it.